Hello students, today we will be solving Pure Maths Paper 1, Variant 3 from May-Jun 2016. Question number 1. Find the coefficient of x in the expansion of 1 over x plus 3x squared to the power 5. So let's first use the formula, which is 5cr 1 over x to the power 5 minus r and 3x squared to the power r. So coefficient of x means x to the power 1. So we need to figure out what will be the value of r for which we will be getting the coefficient of x. So let's isolate the x terms only. So we will be getting x to the power negative 5 minus r because x is in the denominator. And then x to the power 2 times r, which is x to the power 2r. This must be equal to x to the power 1. Simplifying this, we get x to the power negative 5 plus r times x to the power 2r equals to x to the power 1. Since there is a multiplication, that means we need to add these two powers. So it will be x to the power minus 5 plus r plus 2r equals to x to the power 1. Simplifying this, we get x to the power 3r minus 5 equals to x to the power 1. With the help of equality rule, we get 3r minus 5 is equals to 1. Therefore, 3r is equals to 6. That means r must be 2. Now, we can use this value into this formula and we will get 5c2 1 over x to the power 3 because 5 minus 2 is 3 and 3x square whole square. This gives us 10 times 1 over x cube times 9x to the power 4. Simplifying this, we get 90x. So the coefficient of x must be 90. Question number 2. The diagram shows part of the curve y is equals to x cubed plus 1 to the power half. And the point P, which is this, is 2, 3. Lying on the curve, find, showing all necessary working, the volume obtained when the shaded region is rotated 360 degree about the x-axis. So we need the volume and the rotation will occur about the x-axis. So this is the equation of the curve. That means first let's find out y square. So y square will give us x cubed plus 1 to the power half whole square, which gives us x cubed plus 1 because half times 2 is 1. Now the formula which we need to find the volume will be I integration of y squared dx. This is the formula that we will eventually need. But first, what I'm doing here, I'm trying to integrate this. So this will be x to the power 3 will become 3 plus 1, 4, and 1 over 4 plus 1 will become x plus c. So for the volume, it will be pi integration y squared dx, and the limit must be 2 and 0. So these are the two limits. Now we simply have to substitute these two values into this equation. And since we are finding the volume, we do not require the constant. So simplifying this, we get 6 pi. After substituting the value of 2 into x and the value of 0 into this x, then we get 6 pi. And in decimals, it is 18.8 because in the question, they have not asked us to answer in terms of pi, so we can give the answer in decimals. Question number 3. A curve is such that dy by dx is equals to 6x squared plus k over x cubed and passes through the point P 1, 9. The gradient of the curve at P is 2. We need to find the value of the constant k. So since the gradient of the curve at P is 2, that means when x is 1, the gradient is 2. And the equation that we are provided with is the equation of the gradient. So we can substitute x equals to 1 and dy by dx equals to 2 into this equation. So dy by dx becomes 2 and x becomes 1. That gives us, simplifying, 6 plus k equals to 2. That means k must be negative 4. In the second part of the question, we are asked to find the equation of the curve. So now we know the value of k. So previously the equation was 6x squared plus k over x cubed, but k is negative 4. So we can write it as 6x squared minus 4 over x cubed. So in order to find the equation of the curve, we need to integrate this equation. So integrating 6x squared minus 4x to the power negative 3, which becomes 2 plus 1 is 3, and 6 divided by 3 is 2, and x to the power 3. Minus 3 plus 1 is negative 2. So minus 4 over negative 2 will give us positive 2, and x to the power negative 2 plus c. So we need to find this constant with the help of the point P. The point P was 1, 9, and point P lies on the curve. That means this coordinate must satisfy the equation of the curve. So now we have to simply substitute this value into the equation of the curve. So 9 is equals to 2 times 1 cube plus 2 times 1 to the power negative 2 plus c. That gives us 9 is equals to 4 plus c. So c is equals to 5. So the equation of the curve must be y is equals to 2x cubed plus 2x to the power negative 2 plus 5. Question number 4. The first, third, and 13th terms of an arithmetic progression are also the first, second, and third terms, respectively, of a geometric progression. The first term of each progression is 3. We need to find the common difference of the arithmetic progression, which is d, and we need to find the common ratio of the geometric progression, which is r. So from the question, we understand that a equals to a. That means I'm talking about this is the arithmetic term, and this is the arithmetic progression, and this is the geometric progression. So the third term must be a plus 2d for the arithmetic progression, and the second term for geometric progression is ar. Similarly, the 13th term for the arithmetic progression is a plus 12d, and the third term for the geometric progression is ar square. According to the question, these are equal. And it's also given that the first term of each progression is 3, so a is equals to 3. So what we can do, we can substitute this value into the second equation, and we get 3 plus 2d equals to 3r. So 2d is equals to 3r minus 3, and let's call this equation number 5. Now with the help of equation number 3 and 5, so 3 plus 12d, now we know that a is 3 and plus 12d equals to ar square, where a is 3. So 12d is equals to 3r square minus 3. So 4d is equals to r square minus 1, or we can say 2 times 2d equals to r square minus 1. The reason why I took 2 common and made it 2d so that it is easier for me to substitute this equation number 5. In equation number 5, I have stated that 2d is equals to 3r minus 3. Now you can see that with the help of equation number 6 and 5, I can say that instead of 2 times 2d, it will become 2 times 3r minus 3, because 2d is the same as 3r minus 3. So 3r minus 3 equals to r square minus 1. So 6r minus 6 equals to r square minus 1. So negative r square plus 6r minus 6 plus 1 equals to 0. So negative r square plus 6r minus 5 equals to 0. Now multiplying both sides with negative 1, we get r square minus 6r plus 5 equals to 0. Now if we do middle term break for this equation, we get r square minus 5r minus r plus 5 equals to 0. Taking r common, we get r minus 5. Taking negative 1 common, we get again r minus 5 equals to 0. So the factors are r minus 1 and r minus 5 equals to 0. That means r is equals to 1 and r is equals to 5. But we know that r cannot be 1. For a geometric progression to happen, r cannot be 1. Because let's say the first term of a geometric progression is 2. and if you have the common ratio is 1, you have to keep on multiplying 1 with the first term and then the next and then the next. So if I multiply 1 with 2, it gives me 2. So it's not going anywhere. That's why for common ratio, it cannot be 1. That means R has to be 5. So now let's look into the equation that we have made earlier, which was 2d is equals to 3r minus 3. Now since r is equals to 5, we can substitute this value into this equation. That gives us 2d is equals to 3 times 5 minus 3. Therefore, d is equals to 6. Question number 5. A curve has equation y is equals to 8x plus 2x minus 1 to the power negative 1. We need to find the values of x at which the curve has a stationary point and determine the nature of each stationary point, justifying your answers. So this is the equation of the curve. So let's differentiate it first. So 8x will become 8, and then let's differentiate this. So minus 1 times positive 1 is negative 1, and 2x minus 1 to the power negative 1 gives us negative 2. And then inside differentiation, we must not forget to do inside differentiation. So after we are done differentiating the power, we also need to differentiate the things within the bracket. So this one will become 2. So simplifying this, we get 8 minus 2 times 2x minus 1 to the power negative 2. And we know that at stationary point, dy by dx is equals to 0. That means 8 minus 2 over 2x minus 1 to the power 2 is equals to 0. I have brought this one to the denominator and the power became positive. So now what I did here, I did LCM. So this becomes 8 times 2x minus 1 to the power 2 minus 2. And after doing LCM, I multiplied this with 0. So this became 0. So I'm expanding this now with the formula a minus b whole square. So that gives us 8 times 4x square minus 4x plus 1 minus 2 is equals to 0. Simplifying this, we get 32x square minus 32x plus 8 minus 2 equals to 0. So 32x square minus 32x plus 6 equals to 0. If I divide both sides with 2, I get 16x square minus 16x plus 3 equals to 0. So 16x square minus 12x minus 4x plus 3 is equals to 0. So I have done the middle term break. So 16 3 is a positive 48. That means we can take the factors negative 12 times negative 4, which gives us positive 48. At the same time, negative 12 and negative 4x gives us negative 16x. So now let's take 4x common. That gives us 4x minus 3. And then if we take negative 1 common, we get 4x minus 3 again. So the factors are 4x minus 1 and 4x minus 3 is equals to 0. Therefore, x must be 1 over 4 and x must be 3 over 4. Now, these are the two x values at which the stationary point occurs. Now, we need to deal with the remaining part of the question, which is we need to determine the nature of each stationary point. And for the first part, we only had to find the values of x, not the whole coordinate, just x. So to find the nature of the stationary point, we have to find the second derivative, or you can say double differentiation. So 8 minus 2 times 2x minus 1 to the power negative 2 was our first derivative. So second derivative will be 0 plus negative 2 times negative 2 is positive 4, and 2x minus 1 to the power negative 2 negative 1 gives us negative 3. Now let's substitute the values of x for which stationary point occurs. The first x value that we had was 1 over 4. Substituting this value into this equation gives us 4 over 2 times 1 over 4 minus 1 whole cube, which is negative 32. Since it is less than 0, the point is a maximum point. And for the other value of x, if we substitute this again into this equation, So it will be 4 over 2 times 3 over 4 minus 1 whole cube. That gives us positive 32. So since it is more than 0, the point is a minimum point. Question number 6. The diagram shows triangle ABC where AB is equals to 5 centimeter, AC is equals to 4 centimeter because 3 and 1 is 4 and 3 and 2 is 5, and BC is 3 centimeters. So this is 2 and this is 1. Together it's 3. Three circles with centers A, B, and C have the radius 3, 2, and 1 respectively. The circles touch each other at points E, F, and G lying on AB, AC, and BC respectively. We need to find the area of the shaded region EFG. So our objective is to find the area of the triangle, and then we can take away the area of these three sectors. Then we will be left with the area of the shaded region. So for the triangle ABC, if you look closely, you get to see this is 5 centimeter in length, and of course it's already given. AB is 5, AC is 4, and BC is 3. This is a right angle triangle because you must know that 3, 4, 5 is always the right angle triangle. So regardless, I have showed you why is it a right angle triangle, because AB square is 5 square, which is 25, and AC square plus BC square is 4 square plus 3 square, which also give you 25. Therefore we know that AB square equals to AC square plus BC square. That is the formula for the Pythagoras theorem, and that can only exist if the triangle is a right angle triangle. So ABC is a right angle triangle. Now what we can do is find the angles. So sine BAC, if I consider this angle, so sine BAC will be opposite by hypotenuse. So 3 over 5 gives you 0.6, and sine ABC, if you consider this angle, you get opposite by hypotenuse, which is 4 over 5, which is 0.8. So the area of triangle ABC is also half times base times height, perpendicular height, which is 6. And for the angles, BAC must be sine inverse of 0.6. So BAC is 0.6435 in radians, and angle ABC must be sine inverse of 0.8, which is 0.9273 in radians. Now let's find the area of the sector AEF, which is this sector. We know this angle already. This angle, also the angle which is ACB, it's 90 degree. So area of the sector AEF will be half r square theta, and the radius for the circle with center A is 3. So it will be half times 3 square times 0.6435. That gives us 2.8958. And area of sector BGE is half r squared theta, where radius is 2, and the theta is 0.9273. That gives us 1.8546. And area of the sector CGF is half times 1 squared times pi by 2, which is 90 in degrees. So that gives us 0.7854. So the area of the triangle, this was the area of the triangle, which is 6, the whole thing, minus these three sectors, minus some of these three sectors. So 6 minus these three values, that gives us 0.464, and that is the area of the shaded region. Question number 7. The point P xy is moving along the curve y is equals to x square minus 10 over 3 x to the power 3 by 2 plus 5x in such a way that the rate of change of y is constant. Find the values of x at the points at which the rate of change of x is equal to half the rate of change of y. So y is equals to this. So we need to find the rate of change of x. That means we have to find uh, the values of x for this particular equation. So the equation is that rate of change of x is equal to half the rate of change of y. So you have to understand the question here properly, and it consists of 7 marks. So this was the equation. Let's start solving. So y is equals to x square minus 10 over 3x to the power 3 by 2 plus 5x. Now differentiating this, we get 2x minus 3 by 2 times 10 by 3 gives us 5 times x to the power 3 by 2 is basically 1.5. So 1.5 minus 1 is half, and plus 5. And dx by dt, this is from the question. We got that rate of change of x is half the rate of change of y. That means dx by dt must be equal to half of dy by dt. Okay, so we know that dy by dt is equals to dy by dx times dx by dt. That is the chain rule. That is the chain rule. And the reason why we are using this, so that we can use these data and substitute into this equation. So now we can also say that dy by dt So dy by dt can also be written as dy by dx times, instead of dx by dt, we can say half of dy by dt. According to the question, it was given that dx by dt equals to half of dy by dt. So we are simply replacing it with this. Now it becomes more easier to solve. So now let's make dy by dx the subject, because we have the values of if we make dy by dx the subject, it is easier to solve, because by making dy by dx the subject, this goes to the right. That means the fraction will flip. It will become 2 over 1, and dy by dt will become dt over dy. Then you can see that dy and dy, they can cancel out, and dt and dt, they also get cancelled out. So you are left with dy by dx is equals to 2. So that means this equation is equal to 2, because dy by dx is equals to 2. So we can now simplify it further. So it will become 2x minus 5x to the power half plus 3 equals to 0. Now I'm considering let a is equals to x to the power half, because you should be able to recognize the quadratic equation. I can see that this is a quadratic equation. If I consider a to be x to the power half, you will also be able to see that. So if a is x to the power half, that means x will be a square. So this will be 2a square minus 5a plus 3 equals to 0. Now it is easier for you to see that this is a quadratic equation by substituting a as x to the power half. So doing the middle term break, we get 2a square minus 3a minus 2a plus 3 is equals to 0. So if we take a common, we get 2a minus 3, and by taking negative 1 common, we get 2a minus 3 again. So the factors are a minus 1 and 2a minus 3 equals to 0. Therefore a is equals to 1 and a is 1.5, which means x to the power half is equals to 1 and x to the power half is 1.5. So if I square both sides, I get x is equals to 1, and if I square both sides, I get x is equals to 2.25. So these are the x values they were looking for which the rate of change of x was equal to half the rate of change of y. Question number 8. Show that 3 sine 10x minus cos x plus 1 equals to 0 can be written as a quadratic equation in cos x, and hence solve the equation 3 sine x 10x minus cos x plus 1 equals to 0 for x lies between 0 and pi, and both these values are inclusive because it is less or equal to. Okay, so we have to first write this equation in terms of cos x. So tan x can be written as sin x over cos x. So this becomes 3 sin square x over cos x. Sin square x can be written as 1 minus cos square x. So simplifying, expanding the brackets, we get 3 minus 3 cos square x. Now if I do the LCM by multiplying cos x with 0, but before doing that, I have to multiply this cos x with this, and I will be leaving this the way it is because I already have the cos x in the denominator. So 3 minus 3 cos square x minus this will become cos square x, and this will become cos x equals to 0. So negative 4 cos square x plus cos x plus 3 is equals to 0. By multiplying both sides with negative 1, we get 4 cos square x minus 3 equals to 0. Now let's consider a to be cos x. So 4a square minus a minus 3 is equals to 0. Doing middle term break, we get 4a square minus 4a plus 3a minus 3 is equals to 0. Therefore, now we can take 4a common, and we get 4a within brackets a minus 1 plus 3 again a minus 1 is equals to 0. So the factors are 4a plus 3 and a minus 1 equals to 0. Therefore, a must be negative 3 over 4 and a must be 1. This value in decimals is negative 0.75, and cos x is equals to 1 because I was substituting, I was solving this equation with the help of substitution. So now I can say that cos x equals to negative 0.75 and cos x equals to 1. Now let's find the basic angle. So alpha is equals to cos inverse of positive 0.75. Even though it's negative, I'll be taking positive because I'm finding the basic angle. So that gives us alpha is equals to 0.7227 in radians. And we have to find this in radians because the limit that we are provided with is in radians. So make sure that you do check your calculator when you're dealing with sine, cos, and tan. Read the question, see the limits, and then change the mode accordingly. So now with this value, which is negative, we can understand that cos is negative in the second and third quadrant. But since our limit is between 0 and pi, that means we can only take the value from the second quadrant. And basic angle is equals to cos inverse 1. Therefore, basic angle is equals to cos inverse of 1 is equals to 0. Again, positive cos lies between lies in the first and the fourth quadrant. Again, since our limit is between 0 and pi, we have to take the value from the first quadrant only. So the actual angle, which is x, must be pi minus 2.42 because in the second quadrant we the value, the way we get the value from the second quadrant is by taking away the basic angle from the value of pi. That gives us 2.42. And for this one, the basic angle is the actual angle because 0 is inclusive. So we can take the value 0. So the x values are 0 and 2.42. Now let's move on to the second part of the question. It says that find the solutions to the equation 3 sin 2x tan 2x minus cos 2x plus 1 equals to 0 for x lies between again 0 and pi. If you look at the question carefully, you get to see that it is closely related to the first part of the question. In the first part, we had 3 sin x tan x cos x. So this x is getting replaced by 2x. So we know that when the angle changes, we have to fix the limit first. So now this is no longer x lies between 0 and pi. So we have to fix it first for our initial steps. Then we can move on to this limit. So in order to get 2x, I have to multiply everything with 2. That gives us 0, 2x and 2 pi. Now let's consider 2x to be a. So a lies between 0 and 2 pi. We have previously found the basic angles. So it will be the same for this as well. So 0.7227, but now we will be taking, since cos was negative, it the value for cos inverse of points negative 0.75 lies in the second and third quadrant, and we have to take both of this now because the limit have changed to 2 pi. That means uh, we can take these two values. So it will be 2.42, and for the third quadrant it will be pi plus the basic angle, which gives us 3.86. And for the other one, which was basic angle is equals to 0, we can take this also, the value from the fourth quadrant, we can consider that as well because we have the limit up to 2 pi. So 2 pi minus 0 is 2 pi, and in decimals 2 pi means 6.28. So basically we got the values of A. A is 0, 2.42, 3.86 and 6.28, which is the same as 2x is equals to 0, 2.42, 3.86 and 6.28. But we are asked to find the solutions, and the limit was x lies between 0 and pi. So we have to divide all of these values by 2, and we will be getting 0, 1.21, 1.93 and 3.14. Question number 9 is related to vectors, which is not in the syllabus at the moment. Question number 10. The function f is such that fx equals to 2x plus 3, where x is greater or equal to 0. The function g is such that gx equals to ax squared plus b for x is less or equal to q, where a, b, and q are constants. The function fg is such that fgx equals to 6x squared minus 21 for x is less or equal to q. We need to find the values of a and b. So these are the equations. So for the composite function, this must be, if we use these two functions and we form the composite function, it must be that g of x is getting substituted into f of x. So it will be 2ax squared plus b plus 3. That gives us 2ax squared plus 2b plus 3. According to the question, the composite function we got must be equal to the composite function they have provided us with. So let's now compare these two equations. So we can say that 2a, which is the coefficient of x squared, must be equal to 6, which is also the coefficient of x squared. That means a is equals to 3. Similarly, the constant, which is 2b plus 3, must be equal to the constant negative 21. So therefore, 2b plus 3 is equals to negative 21. That means 2b is equals to negative 24. Therefore, b is equals to negative 12. In the next part of the question, find the greatest possible value of q. So these are the equations of the function fx, gx, fgx. For this, you have to understand that although it is of 2 marks, but it is actually a bit of conceptual. So what you need to think is, for the composite function to exist, the output of g of x must satisfy the input of fx. So again, I'm saying this, for this composite function to exist, the output of g of x must support the input of fx. That means this equation, which is the equation of gx, 3x squared minus 12, must be greater or equal to 0. That is the input of fx. So taking 3 common, we get x squared minus 4 within brackets, and if I divide both sides by 3, I get x squared minus 4 is greater or equal to 0. So x, I'm now breaking it down with the help of the formula a square minus b square is a plus b and a minus b. So since 4 is a square number, it will be x plus 2 and x minus 2 greater or equal to 0. Therefore, x is the values, the critical values are x is negative 2 and x is positive 2. Now with the help of the number line, it will be a U shape because the quadratic equation is positive. So it will be a U shape, and these are the numbers that we have found. Now for the equation to be greater or equal to 0, x must be less or equal to negative 2. This part is positive. And for the equation to be greater or equal to 0, again, x has to be greater than 2 because this side is positive. But in the question, we saw that x is less or equal to q. That means we have to discard this value and just take this, which is x is less or equal to -2. That means q is equal to -2. And this is the greatest possible value of q, and it goes below this. Okay. In the next part of the question, it says that now, given that q is equals to -3, we need to find the range of fg. So the composite function was 6x squared minus 21 for x is less or equal to -3. This is the condition that they have provided us with. So when x is less than -3, the composite function must be 6 times -3 whole square minus 21, which gives us 54 minus 21, which is equals to 33. Now you need to understand, before you even state the range, is how the shape of the graph for this function will look like. We know that the default x square, just the x square, the graph starts at 0. Okay, and from 0 it goes upwards, and the number next to it, which is 6, it only affects the curvature of the curve. But this -21 will bring the curve down by -21 units. This point is basically -21. This is what you need to think of. So when x is -3, that means -3 must be on the left side of this graph. It will be over here somewhere, and we can see that the graph is going upwards since this is a positive quadratic equation. So since this is a positive quadratic equation, that means it will definitely be a U-shaped graph, and it's going upwards. From -21, it's going upwards. So for -3, it will be here somewhere. Still, the graph is going upwards. That means the range is greater or equal to 33. Now, in the next part of the question, they have asked us to find the expression for the inverse of the composite function, and we need to state the domain of the composite function as well. So let's consider y is equals to fgx. So y is equals to 6x squared minus 21. Making 6x squared the subject, we get y plus 21. So x squared will be y plus 21 over 6. So x will be plus minus square root of y plus 21 over 6. Now, since y is equals to fgx, therefore fg inverse of y must be x, which means fg inverse of y must be plus minus square root of y plus 21 over 6. So fg inverse of x must be plus minus square root of x plus 21 over 6. But since our domain for the composite function was x is less or equal to -3, that means we should not be taking the positive value because it will go into the positive direction. We have to take the negative, so it gives you less values, values which are negative basically. So it will be square root of x plus 21 over 6. And the domain of the composite function will be the range of the normal function. This is the inverse function, and the normal function was fgx. So the range of the normal composite function was fgx is greater or equal to 33. This is the range for fgx. So that means this number will become the domain of the inverse function. So the domain will be x is greater or equal to 33. Question number 11. Triangle ABC has vertices at A -2 -1, B 4 6, and C 6 -3. Show that the triangle ABC is isosceles and find the exact area of this triangle. So AB square is equals to 4 plus 2 whole square plus 6 plus 1 whole square. That gives us AB square equals to 85. So AB is square root of 85. So I'm trying to find the lengths of all the sides or all the edges of the triangle. So AC square equals to 6 plus 2 whole square plus negative 3 plus 1 whole square. This is the formula that we use to find the length. So which is, the length is equals, the length squared is equals to x1 plus x2 whole square plus y1 plus y2 whole square. Sorry, the formula does not contain plus, it will be minus. So square root of x2 minus x1 whole square plus y2 minus y1 whole square. So for AC, we are getting 2 square root of 17. For BC, we are getting square root of 85. Now you can clearly see that AB and BC are of equal length. So therefore the triangle must be isosceles, as AC is different. If AC were to be same as square root of 85, it would have been a equilateral triangle. But this is not the case. We have two equal sides and one with a different side length. So this is an isosceles triangle. So this has been proven. Now we need to find the exact area. So for that, what we need, what we can do, one of the way could be, let's find the angle ABC. With the help of the cosine formula, I can say that square root of 85 square, which is this. So AB square plus BC square minus AC square over 2 times AB times BC. That gives us cos ABC is equals to 3 over 5. So with the help of this, I can understand that this is again a right angle triangle, because if the adjacent is 3 and the hypotenuse is 5, that must mean that the other side will be 4. If you are very confident about the 3 4 5 right angle triangle, that saves you a lot of time. So BC square is equals to 5 square minus 3 square, which is 4. This is what I have explained also. Now sine ABC is equals to 4 over 5. So sine BAC is equals to sine ABC, sorry, ABC is opposite by hypotenuse, which is 4 over 5. So area of the triangle, we can use the formula half times A times B times sine theta. So the angle must be between the two known sides. So half times root 85 times root 85 times the angle between them is sine BAC, and BAC is 4 over 5. You can look at the question again. It says that we have to find the exact area. So we have to keep this in mind throughout the question. That is the reason why I'm not making these decimals. So sine BAC is 4 over 5. So this becomes, we are getting root 85 getting multiplied with itself. So that makes it just 85 over 2 times sine BAC is 4 over 5. Sorry, this will not be BAC. This will be ABC. I think I made a typo error. So it will be ABC, which is 4 over 5. So 17, this will give you 17 times 2 is equals to 34. So this is the exact area of the triangle. Now let's move on to the next part of the question, which says that the point D is the point on AB such that CD is perpendicular to AB. We need to calculate the x coordinate of D. So these are the points, and let's draw a triangle. So this is ABC, where AB and BC are of equal length, and the line CD is perpendicular to the line AB. And let's consider the point D to be x and y, because that is unknown, and we have to find the x coordinate only for the point D. So equation of line AB, we can use the formula where we know 2 points. When we know 2 points, we can use the formula y minus y1 equals divided by y2 minus y1 is equal to x minus x1 over x2 minus x1. That gives us y plus 1 over 6 plus 1 and x plus 2 over 4 plus 2. Simplifying this, we get y plus 1 over 7 equals to x plus 2 over 6. After we do cross multiplication, we get 6y plus 6 equals to 7x plus 14. So 6y is equals to 7x plus 8. So y must be 7x over 6 plus 8 over 6. Let's consider this equation 1. So equation of the line CD. The way we can get this is, we know that the line AB and the line CD are perpendicular to each other. That means the gradient of the line AB, we can use the formula which is minus 1 by m to find the gradient of the perpendicular line. So if the gradient of AB is 7 by 6, that means the gradient of CD must be minus 6 over 7. And we also know a point on the line which is C, which is 6 and negative 3. So we can use that point and the gradient to find the equation of the line CD. So y minus minus 3 equals to minus 6 over 7 times x minus 6. So the formula I'm using here is y minus y1 is equals to mx minus x1. So that will give you 7y plus 21 is equals to negative 6x plus 36. So 7y is equal to negative 6 plus 15. So y is equals to negative 6x over 7 plus 15 over 7. Now let's call this equation 2. So this was the equation of the line AB and this is the equation of the line CD. Now since these two equations will be meeting at the point D, that means we can equate these two equations. So I have just simply equated y equals to y. So simplifying this, we get 7 times 7x plus 8 equals to 6 times negative 6x plus 15. If you do LCM, you get 6, and if you do LCM for this side, you get 7. So 49x plus 56 equals to negative 36x plus 90. Therefore 85x equals to 34. That means x is equals to 34 over 85, which gives you 2 over 5. And that is the x coordinate they are looking for. And that will be all for now. I will see you in the next video.